Hmm, I can't hear you guys. Can you?
Hey Sandeep, good
Hey,
evening.
Ren, how are you doing?
Doing good, sir. How are you doing?
Good, 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 good. Hmm. Matt Subodh had come this week here, Toronto.
Subodh is your ex-colleague from Amazon also?
No, no, no.
Okay. So first time you met.
Yeah,
So when you coming to India or no plan?
you come over.
Citibank don't send anybody to anywhere
Huh?
except their base location.
I see. I see. Come on your own expense for a summer vacation or something. It's you know,
But your whole team is in India, right? Most of lot of
yes,
people
yes.
are
Everybody is in India
except you.
except for me.
So you are the single man army running all the show here and there, marketing, sales.
No, there are team. The team is doing.
Acha, you have other folks also. Okay.
Yeah, yeah. There is Gajender, Gargi, Tezveer, Amit, and a few more people. Three people in tech. So um, mostly moving into AI. Basically the AI projects and AI um, products, basically.
Okay.
Launching something like text to SQL very soon, and working on 3, 4 projects. And yeah, there's a lot of, a lot of great stuff happening now. The neural network and everything is very much, practical and, very useful in general. So it's no longer like a, it's no longer like a, you know, fantasy, or it's no longer like a research area. It's more of like applied area now. Everybody is trying to apply it in different domains. So now is a good time. Now is a good time. And yeah, and now is the good time to actually try out all kinds of things. Okay. So that's why I'm moving. It's naturally happening. Since the time I have come here, it's naturally happening. So I gave a talk here in Toronto, and lots of people came. And people keep on coming and approaching for different kind of projects and so on. And now that thing is unfolding. So yeah, and let's see how it goes.
No. I think everything will go well, sir.
I think Sandeep also wants everyone to come to Canada in summer to get sunburned along with him as well. I feel that's his hidden intention.
Dude, in December, I honestly want to come to India and chill out for like 2, 3 months in Goa and then go back. So from December till March, I want to hang out in Goa. Okay. And
That sounds like a good plan. If you're planning to do that, just let me know. I'll also join you.
in 2020, January, okay, I stayed in Goa along with my team for 1.5 months there. Okay. And I had decided to live in a hostel for the first time in my life, just for the experience. It was a good hostel. A good
Did you
hostel.
meet a lot of foreigners and like a wide group of people?
Oh, yeah, yeah, all kinds of people. All kinds of people. And before meeting foreigners and all, I used to have this impression that most of the foreigners are educated people. But when I met people in the hostel, then I realized, oh, somebody is a woodcutter, somebody helps set up the speakers, and right. So
But yeah, but they get paid good amounts for those. If you compare to like in India,
yeah,
probably where a carpenter gets like at max, hopefully he gets like around 20, 30,000
yeah,
per
yeah,
month. They are
yeah,
making bank over there.
yeah, yeah. I think that's a very interesting observation that I had during that time when I met lots of people from different countries. That that the the kind of professions I had seen in my childhood in the village, that kind of professions still exist here. Okay, and they are well paid. And after coming here, I'm seeing like there are people who like there are many people who don't like coding, and those who don't like the programming or something. Or you can say that they don't want to learn. So what they have done is they have moved from software engineering to plumbing job. Okay, so they did the plumber course, and that's it. Okay. And I'm thinking of joining military here, army. Okay. Yeah.
Really?
Yeah. I'm thinking. And you can do it part-time here. Okay. So one of my friends who registered my company, Nick, he's a software engineer 3 days, 4 days a week. And 3 days he goes for military camp. So he has done that. So he basically does it. And I met him. Okay. I did not realize. I thought, okay, maybe earlier in his young age, he was doing military. But it was very surprising. I met him. He gave me entire round. He showed me all the guns and the entire uh, things, and it was interesting. And he said that you can join, you can just come. If you are on a permanent residence or you are a citizen, you can just come here and they will pay you and you'll stay fit. You'll have to pass the fitness test. That's all. Okay. There is no age bar or anything. So I think I'll join. The moment I get some time, I'll join military or army here.
Probably
Part.
the next time we see you, we'll see two guns behind you as well.
It'll be fun.
That'll be
Okay.
fun.
Okay, so how is it going with everyone? Where are we with respect to the yeah, we were talking about the sentiment analysis, correct? And yeah, did anybody set up and were you able to do the OpenAI embeddings? No?
I tried it, Sandeep, but I was getting invalid API credentials, so I don't know why. I was not given I didn't get any option for the card details to enter. So I don't know. Maybe I missed something.
Okay. No, you have to just add that card detail only, then it'll allow. I was having the same issue earlier. Okay. Then I put the card details and also I set the default key that this is my default name or domain name or something like that. Okay. So that was another issue. All right. Okay. Okay. And yeah. I will put this notebook in general. All right. So we talked about all of this, right? Everybody is comfortable with this? All right. So I'll just give you a brief. Okay. So it's okay. You can think of it that the machine learning has started. Okay. And we will go back and forth with Python. Don't worry. And I don't want everybody to be hanging in the air for, you know, for a bit of, for the machine learning. Okay. So agenda is very, very simple for me. The agenda is that, you know, for all of you, Okay. So one is you should be good with Python. Then you should be good with maths. And then to achieve both of the, and then you have to be comfortable with right, ML algorithms. Okay. And then to achieve all of these things, whatever libraries are there, you should be comfortable with that, right? Data cleaning. So with this, basically with all these three sets of knowledge, right? You'll be able to do like data analytics, and there'll be other things like Linux and SQL. Okay. With these basic tools, you should be able to do data analytics, data science, machine learning, and right, data engineering and everything. All right. So this is like a fundamental part. These are like 5 fundamental things that you guys need to be comfortable with. But the question is, Python, you know how much? SQL and Linux is very clear. Both of these are there in the code, self-paced model. These two things, I would go slowly in a way that you don't realize that you are doing advanced maths. And I don't want to make you feel that since you don't have background in maths, therefore you are not able to understand. Okay. So I'll be jumping back and forth between maths and coding, and in this duration, you will learn everything. Okay. All right.
Sandeep, anything you're gonna do is share material on the maths? I don't think so. There is anything in the course library also, right?
Don't worry, it'll come.
Do we have to do DevOps as well along with this? I mean, yeah.
Okay. Personally, yeah, you should just know right. Most of the DevOps is a combination of Python and Linux, and on top of it, if you are comfortable with Docker,
yeah,
Kubernetes, okay, and rest you will be able to handle. Okay.
Yeah.
And yeah, basically, what I found is that the missing piece in DevOps, when I see lots and lots of engineers, they have done great courses of AWS and GCP and so on, but what they learned was just to copy paste this stuff, or not only copy paste, just use their web interface. Okay, use the web interface of AWS and GCP, and they became very. I was recently hiring for one of my the company I consult. I was recently hiring these data engineers and DevOps engineers for one of the companies in Montreal. And what I found is that most of the people that I interviewed, most of them were basically like, you know, they can go to website, the GCP, and do the things, or AWS do the things, and they call themselves DevOps people. But when it comes to even fixing a little bit of code, they are not able to handle that part.
Yeah.
Okay. And that's why coding is so important. Coding and comfortable with being Linux, working with Linux and SQL is so important that it's so understated. And other thing is that when you basically cover these, okay, I'll just move this outside. Okay. So when you cover these parts comfortably at your own pace, okay, you will be these fundamental part. Okay, you will be able to do rest of the things by yourself. Okay, and the hardest part of the entire course, which I realize, is the Python part. I mean, not to Python, but converting thought into code. Converting thought into code is the hardest part out of all. I have met lots of data scientists who can tell me everything about algorithms and so on, but they can't write the matrix multiplication for me. Okay. So that's a very weird thing to see. Okay. And because of that, I'm not able to hire.
Like, yeah, I mean, this is exactly the same situation I'm at. Like, I feel comfortable. Like, understanding the course and whatnot. But when it comes to, putting it on the paper, the struggle starts actually.
Okay.
So I know it's takes some time. And coming back on the DevOps things, that's what I mean. I realized like I've done almost that half of your course actually, the DevOps course.
Okay.
I know I do have the good understanding of this now tool sets that are there, but the problem it's a weird problem I'm facing it up. Like I'm giving a try to apply to jobs, but these companies are basically, looking for you should have Azure certification in DevOps and looking certifications for AWS apps. So kind of that's where I feel like lagging it up. The problem that is, with job, with this course coming up, with kids, family, it's hard to go for the other certifications as well.
Right.
And so I don't know, I'm finding it hard to put the balance.
Where are you in Australia?
Sydney.
Sydney. Okay.
Yeah.
Okay. All right. Okay. Okay. And okay. Okay. And yeah, I think we should catch up sometime. So separately also. Yeah, I'll give you my calendar.
Sure.
Now coming back to it, so essentially, yes, that certification part is a thing, okay, but if you get internal referral in the company, you usually don't have to worry about any of that. Okay.
Yeah.
So do let me know. I have some friends in Sydney and I can connect you there. Okay. And the other thing is, I mean, for all, if you can just quickly go through these certifications, most of these certifications are like a sham. It's like most of the certifications which I've seen from AWS, GCP, they tend to focus a lot on their UI and this and that.
Their products, right? Rather than learning about it.
And therefore, most of the companies do not really, those who are just focused on GCP certification, right? Even if they do hire based on GCP certification and whatnot, but eventually they don't get it, to be productive in the sense that tomorrow if they move to AWS, they kind of lose it. So yeah. I can't change companies that they right, but what you can do is you can just go for one quick certification and you'll be able to clear it very quickly. Don't worry about it. Okay, you'll be able to very quickly clear it, and most of it like very basic. Okay, very basic. So and yeah, just make yourself super comfortable with Linux and other things.
Yeah. No, I want like my learning to be technology agnostic. I don't want to depend on AWS or Azure or GCP to decide on my future. But again, I mean, everything comes down to the end where getting the jobs and whatnot. That's where the problem starts. Like when they put the certifications in.
Yeah.
That's
so it's kind of a very weird thing. Okay.
Yeah.
So a company basically, right? They get some sort of AWS discount on those certifications and so on. I think, but you can't help it. You can't help it. Okay.
Yeah.
Anyway, I think we'll discuss this part. Okay. So last time, what we did was we did a simple thing. This particular one we did here. This one, right? This is the notebook that we talked about, right? Okay. All right. So basically, vector started with that magnitude and direction. But in simple words, the way you should think of a vector, not in terms of direction, magnitude, or anything, just think of vector as bunch of numbers. Okay? Bunch of numbers is called vector. Okay? Like, for example, right? Okay, and vector is also called matrix. In case of right, so vector is bunch of numbers. Okay, and tensor is a better word to use. Okay, to use, like, say for example, tensor of 0 dimension. Okay, 0 dimension tensor is called scalar value, like x equal to 1. Okay, x equal to 1. This is 0 dimension tensor. Okay, now x equal to 1 to 3. This is 1 dimensional vector, 1 dimensional tensor, or you can call it also a vector. Okay, then x equal to, okay, if you think about it, okay, 1, 2, 3, and 2, 3, 4, and 4, 5, 6, right? This is a matrix. People call it matrix, right? This is a matrix, and we call it, it's also called two-dimensional tensor. Okay, so 0 dimension tensor, 1 dimension tensor, 2 dimension tensor, and okay, tell
So
me.
it's 2 dimension or it's a 3 dimension? Because 3 row, 3 column, right?
No. This is, how many brackets do you see? There are 2 brackets, square bracket open, right?
So you count by brackets or you count by row and column, the way we do in the matrix?
So if you see, this could be, right? This would still be the 2-dimensional. Okay. And yes, these dimensions are going to be confusing. So yeah, I'll talk about this, right? So this is a 2-dimensional tensor, right? The shape of this one is 3 rows by how many columns? 3 plus 3 plus 2, 8 columns, right? 3 rows by 8 columns, right? So this is basically 2-dimensional. Got it? Oh, right. Yeah, but it's good that you asked. This is a common trouble. And when we see that in other things, columns will be called the dimensions. Okay, columns will be called the dimensions. So be aware of that fact, that we will be sometimes we calling there so many dimensions of data, right? And like when we draw the line or create a model, that model could be n-dimensional, right? I'll talk about that, don't worry. But this is the genuine confusion, and that confusion I too had when I was beginning all of that, right? Now, let's think about, okay, so can somebody give an example of like 0-dimension tensor? Just give something, like anything, like money in my pocket, right? So or let's say my height, my right now. Yeah, so that's pretty simple. We also call it scalar. Okay, now my question to all of you is that give me an example of like where do you use an array of numbers? Okay, it's pretty simple, this one. Array of numbers, examples, where do you use them? Okay.
You could say for video images, don't you use like an array of numbers?
Yes, just a list of numbers. So for example, my marks in tests, right? Different, I have like multiple tests, physics, chemistry, maths, and so on. That could be one example. What else could be an example of single dimension vector? Okay, go ahead. Any characteristics when we list down, that's a single dimension vector, right? Now, where do we use this two-dimensional vector or two-dimensional tensor? Give an example like a grayscale image, right? Grayscale image is nothing but a 2x3 image, right? We can just say that import from Matplotlib, import pyplot, right, as PLT, and PLT had that function called IAmShow, right? So let's say this is my data, right? I can just try to visualize it. Did I make mistake somewhere? Is this okay? Yeah, this worked. And I can say plot it. It says it has no attribute of doing the okay, plotting an image Python IAmShow. Okay, so it is there, right? Pyplot IAmShow. IAmShow. Okay, so like here you can see it has got 3 rows of data, and it has got okay. Okay, I'll just put some numbers in there.
Yes, Sandeep, I have one question here. This dimensions are hello.
Yes, go ahead.
Yeah, these dimensions are different for the math dimension. Like math, we considering the dot is the zero coordinate and the line A to B is the two dimension. That is different thing or the same thing? A
Okay.
little confused.
Okay.
Like X Y Z, we like try that this is the 3 coordinate. We can.
Yeah. So here we are talking about the dimensions of the tensor. Okay. Okay. And basically dimensions will be using like this is the dimension 2x8 and so on. Okay. So here, strictly speaking, this is the dimensions of the tensor. Okay. We'll say that, okay. Sometimes it's also called, what do you call it? There is another term called total number of dimensions, NDIM, right? So
So
number
here,
of dimensions, yeah.
what
Like
is the XY value here? Like if this plot,
which one?
yeah, this
Yeah,
one
this
also.
one. This one, it took these colors, okay,
Mhm.
did the smallest value it made it black, and rest it made it some color. Okay, it just automatically fills the color with some value corresponding to that number.
But the how to define this axis y-axis minus 0.5 to 2.5. The x-axis is the value that I know that,
Yeah,
but
I'll just tell you.
y-axis, yeah.
I'll just tell you. Okay, so is there a way to make it like grayscale that'll make more sense to you? Okay, all right.
Actually, Sandeep, these numbers in that brackets are like they are changing the color set, according to their frequencies.
Yeah. I'll just tell you that way. Okay. See, all right. I'm using this library called pyplot. Okay. Pyplot can plot a two-dimensional array as a image. Okay. So this color is going to be somewhere this number 0 and 1, right? So what it does is it will take the maximum value, make it white, and will take the smallest value, make it 0, and everything in between. Okay. So what it has done is it has created an image. So you can see that a 2D image is nothing but bunch of numbers.
That means just put the one number and create the one block based on the value of the specific row, right?
So see this row, how many rows it has? 1, 2, 3, 3 rows, right?
Yeah.
How many columns it has? 8 columns, right? This number that you see is the color intensity. 0 here means absolutely black. 8 here means absolutely white. Okay. And 5 is gray. You can see 5 is gray somewhere. Okay.
This
Like
by this by x is just a representation, nothing else, not depend on the these value, right?
which
This
one?
minus by axis minus 0.5 to 2.5 for two,
Y-axis minus this one, right?
left side by axis. Yeah,
This
this
one.
one. Yeah.
Yeah, I just put these things by itself. Okay.
Okay. That's
Yeah. So all it had just put these values by itself and just plotted it. Okay. All right. So if you just want to, duplicate it, you can simply, just take this and duplicate it like this. Okay. So you can see now it has become a bigger image. Good.
But think about that. You add one more, like the element is extra in the first array list, right? First list. But here is the similar structure. How it is defined? Then
I'm
how to define the size of this image? This vector defined as the coloring coding, color number. So how to define the size of these array? Like this image is symmetric, like x and y is all are same in the every array, but in the number is little bit different.
okay. Like if you put it like remove some of them, right?
Yeah, yeah.
Yeah, then it throws an error. Okay.
Only for one that is okay. Like
No, if you make right, all of see this function when it is plotting, so this function is taking this array from you and plotting it, right? It starts at the top. If the next value is not same as the previous value, it throws an error. If
so
that
this seven number is the exclude from this side, this image.
is it?
I don't know.
Wait. No. It's okay because it's like 5.5. So
Okay.
Okay.
Yeah.
So I got it. So it's like it looks like as if it's yeah. It looks very weird. Okay. And yeah. Okay. Now it makes sense to you.
Yeah.
This is now it makes sense to you. Now it's clear, right? So this has to be equal. Okay, that was causing the confusion. Perfect. So 2D array is nothing but basically an image. Now let's take an example of point in 2D, right? Point. Let's define a point. Okay. So okay, let's define a point. Let's say this is my point. If it is in 2D, two dimension, a point is defined like this, correct? So basically, point in two dimensional is represented as a vector, correct?
Okay. Yeah.
Point in 3D is represented as, how would you represent the point in 3D? This is a point in 2D, correct? Point in
Like in
3D
XYZ.
is something like this,
So,
right?
yeah.
XYZ.
So this is point in 2D, 3D, but represented as a one-dimensional tensor. Okay, this is point in 2D. This is a point physical structure. If you see physically, it's a point in two-dimensional world, right? But it is represented as a one-dimensional tensor. Okay.
Yeah.
Now, a point in let's say 20 dimensions, okay? Okay, like 20 dimensions would be right. Basically, even in 20 dimensions, it will be 1D tensor. Okay, so keep this in mind that dimension word would be confusing. You should always ask whose dimension we are talking about. Okay. All right. Are we talking about the object's dimension, or we are talking about the tensor's dimensions? Are we talking about whose dimension we are talking about? Now, let's talk a little bit about
For the
point.
first, we use the term data dimension.
What?
Let's say 1, 2, 3, 23. Can we say these are the data dimensions which are
Yeah.
represented by a single dimensional vector?
Yeah. Correct. Correct. That's how you can always communicate. Okay. That's the right way to do it. All right. Now, think of next thing, very important part. Okay. All right. So you have a point in 2D. You have a point in 2D. Let's call it 1, 2. Okay. If you move it 3 points to the x-axis and 4 points to the y-axis, right? Where will it go? Where will it reach? If you move it 3 points in x-axis and 4 points in y-axis, where will it go?
4, 6.
It will become 4, 6. Correct? Now, basically, the other way to look at it is that my point was 1, 2. Okay, my movement was 3, 4, and I added P and M. Okay, so the point is also a vector. Movement is also a vector, and the basically I just added to move my point, I just added P and M. Okay, so Python provides a nice library called NumPy. I'm importing NumPy as NP. You will observe it very often. I'll go into more details about NumPy later. But here is a cool idea. So you can convert a normal Python array into NumPy array. NumPy array is nothing but a very efficient array, and it essentially is designed to do all the vector things and so on. Okay, so we basically created an array defining our point, and then we created an array defining this movement, like whatever movement we had, and then we can do P plus M. Okay, let's say we want to move the point by 3 in both the dimensions. So I can simply say move point P plus 3, so 3 gets added in both. Okay. All right, is everybody okay?
Yes.
All right, so far you guys are all clear. So now the next thing I want to talk about, I think this much is good enough.
Can we add these 3 to multi-dimensions also using single expression like this?
Good question. Good question. Now imagine this. Okay, let's see. Our task was to do that for the our rectangle. Okay, let's say this is my rectangle. Okay, this is my rectangle, and the length of it is 3, width of it is 4, and this corner is at a coordinate. Let's say this height is how much? This height is, say, let's call it this height. So the way we define coordinate is how much it is in x-axis and how much it is in y-axis. So let's say this distance is how much? Let's say 5 and 6. Okay, so this corner is at 5, 6. Okay, this corner is at 5, 6. So this corner will be at what?
5, 10.
5, 10. 5, sorry, 9, 6.
9,6.
Oh, sorry. Yes.
5 plus 4 is 9 and then 6, right? And this corner will be 9,
9 or
comma
9.
10.
9. Okay. And where will this corner be?
5, 9.
5, 9. Perfect. Right? Now, you got to represent this rectangle by these coordinates. Okay? All 4 of them. Or let's say, right? We want to represent this as a array of points. So how would you represent your shape? Shape will be equal to, right? First is 5, 6, first corner. Second corner is 9, 6, right? And then 9, 9, then 5, 9. Okay. So this is your two-dimensional matrix representing your shape. Notice that here, this data, each of the row is representing each of the points. Correct?
Correct.
All right. Now, if I ask you to move this, move all the points in x-axis, move it by -2, and y-axis, move it by +2. Okay, move each point by -2 in x-axis and +2 in y-axis. Okay, so what you'll have to do, you will have to add -2 and +2 to all of these numbers, correct?
Correct.
That's how you will move the rectangle in this world, correct? So how would you do it using, say, NumPy quickly? You'll just say NumPy, np.array will convert it into a NP array. Basically, it's kind of a list, but more efficient one. Okay, it says that there is a mistake because I forgot the comma. Now, we can say shape, right? Shape plus, we'll just say np.array. And we can just add -2, 2. Okay, so you can see that all of these numbers have been moved, isn't it? Okay. So when you add this number, this got added to all of them quickly. So if you have to move shape, and you know the coordinates of the shape, the corners of the shape, you can simply just add this vector and it automatically gets added to all. Okay, so the point I'm trying to make is that the data that you see in the real world, you can represent it like a vector or vector of vectors, or we can call it tensor. Okay, and then we can do operations on it very comfortably. Okay, let's say I want to increase, I want to multiply each coordinate by 2. Okay, I want to multiply each coordinate by 2, so I can simply say shape into 2. Okay, so suddenly 5 became 10, 6 became 12, and so on. Everything became double. So the shape of this rectangle also became double. Right? So by the way of using these libraries such as NumPy array, you can do these kind of operations very quickly. Instead of you doing it manually every time writing the for loop, this thing will do it for you. Okay? All right, so we learned two things, that we can represent the things that we see in the world in terms of bunch of numbers. And second, we can do operations on it using NumPy array. Okay. Is everybody on the same page so far?
Yep.
Okay. These things look really simple and easy, but soon enough, the moment you lose the control, they kind of become pile up on each other and start looking complex. Okay. Now, I want to ask you, how would a 3D image look to you? Yeah, go ahead. What does it mean by colored image? Okay, let's say colored image.
Cube.
Colored image. So grayscale image, we are clear, right? Grayscale image looks like this, a 2D image, right?
Sandeep,
This is
here
our
one more. In the grayscale image, I have one more negative value is allowed for this tensor.
grayscale. Come again.
Negative value is allowed, like -1, -2.
In case of I am sure. Huh?
Tensor vector, yeah.
See, vector is nothing but bunch of numbers, so you can add all kinds of negative numbers. Okay, any number, right?
Okay.
Any number is allowed. Any number is allowed. Okay, text and other things are not allowed, but true false is allowed in a pi array. Any number is allowed, but I'm not sure about this. Okay, I'm not sure. I'll make this smaller so that it is clear. Okay. Okay. What's happening to this?
C map.
Spaces, comma.
Schema. Okay. Yeah. Okay. Now, I want to make it little sweet and simple. Okay. I'll just make it say array of 2 by 3 columns. Okay. Just to make sure that we are on the same page. Okay. What happened here? Okay. So we just defined a very simple image. This is a grayscale image, correct? Grayscale image. Let's convert it into a color image. Okay. In case of color, this number, rather than being a single number, it will become red, green, blue, right? RGB. So we'll change 1 to, let's say, 3, 4, 5, and then this 4, 5, 6. I'm just putting random number, okay? Don't think that I'm thinking big things, okay? And just okay. So these are the 3 colors: red, green, blue, red, green, blue, red, green, blue, and so on. Now, if I try to plot it, let's see. Okay, it did not work out well. Okay, so would it want me to put it 200? Yeah. Red, this is red, green, and blue. Okay. Why does it look like blue? I'll just say 0 and say 200, 0. Okay. Then I'm saying 0 to 40 and okay. I'll just, yeah, this is okay. I'll just put them like this. Okay. Yeah, now it makes sense to you, right? This is red. Okay. Can you also say 255 for this? Now, is it red? This is very clear.
here.
Okay. Is this red?
I mean, value-wise, it is red. Plus perception is subjective.
This is very weird. Okay. All right. This should be green then, right? Yeah. Okay, so I'm colorblind, so I'm leaving it to you. What color does it look like? But yeah, I hope you got the picture. So I have tried to create a picture containing 4 pixels. This is 1 pixel's value. This is another pixel's value. This is another pixel's value. And this is another pixel's value. Okay. So
Is
now
it
you can, yeah.
taking this as a hex code 255?
Yes, yes. So what is a color in case of computers? We make the color using 3 LEDs. Okay. Every dot in your LCD screen on TV has got 3 LEDs there. 3 LEDs. And LED basically 3 bulbs over there. First bulb, if first one is on or first one has a high intensity, that will give the red. And the second one green and third one blue. So when all colors are there, it's white. When these two are not present, then okay. You can also just try to add more colors here. Okay. So I can say I just want to see red. This is red, this is green, this is blue, and let's say I just want to put one black. Okay. And also just put say 2 of these values. I can just want to show you how the mixing looks like. Now you can see. So this is green and blue. I don't know why does it look like this. Okay. So this is red, green, blue, white, black, and this is green and blue combined together. Okay. Are you guys okay what I'm trying to do here? So here, a colored image, though it's a 2-dimensional image physically, but underneath it is represented by numbers which are structured as 3D object. Correct? These numbers are structured as 3D. You can see 3 dimension. It has got 3 rows. So the shape of this one is what? 3 times 3 rows, 2 columns, and 3 channels. We call them channels. Right? So total number of dimensions are 1 dimension, 2 dimension, number of rows, columns, and the color. Right? This is
What do you mean
rows,
by
columns, and channels or colors. Right? There are 3 channels, 3 colors. Okay. You can think of it as if it has got, we got, 3 images, 3 grayscale images lying one top of another. Okay. The thickness of this object is 3 always. Number of rows could be more, columns could be more, and so on. But yeah. Okay. I can keep on adding as many as I want. Okay. So you can see here, let's say I want to add red, green. Okay. But you can see each pixel is represented by 3 numbers. Okay.
So if you were to add time dimension and a movement, can we create a video using this?
Yes. Yes. Let's see. Okay. So this is your 3-dimensional image, correct? This is your 3D image. Okay. And where did I make mistake here? Okay. Yeah. So good question. So if we take this image, okay, if we have, let's say this is my image, Okay, this is my image. Okay, and basically I define, okay, the first frame looks like this. Okay, first frame looks like this, and okay, second frame looks a little different. Okay, looks a little different. Okay, I'm just changing some of them. Okay, and then the third frame looks a little bit more different. Okay, all right, I'm just putting some random numbers. And okay, and your video is nothing but array of these images. All right, cool. So your video would look like this, right? Your video has 4 dimensions. 1 square bracket, second, third, fourth. Everybody okay so far? All right. You can convert it into a NumPy array by just calling this function. Okay. And you can see the way you can find out is all the functions of NumPy. You can use these functions to do all kinds of things. I'm saying NumPy, give me number of dimensions. Okay. So it says number of dimensions is 4. All right. So we I can't display. I don't know how to display it right now, but if you have to animate it, this is my first frame, this is my second frame, and this is my third frame. Okay. All right. So I hope it's making sense to you. All right. Now, we're coming to a very important part. Underneath, somebody might decide that, okay, I'm going to merge all of these frames and just keep 2D object underneath and then display it using some algorithm. Okay. So it is the prerogative of the designer to decide how do they want to represent the object using the numbers of their own choice. Okay, some people may choose to represent video using a rectangular data set, like the way we have done. Some people might choose that, okay, I'll just figure out how to represent it using 2D and then do that. Okay, so far, I hope everybody is comfortable with the vectors and tensors and so on. Yes? Okay. Did I go too fast? Was it clear? Give me feedback, everyone.
Trying to digest. Sandeep.
Okay. Okay. Ask questions. If you
Clear to me.
Ranbir?
So far okay, Sandeep, for me.
So far, okay. Okay. If there is any doubt, any thought that is coming in that this is complex, I'll have to watch this video again, I think ask right now. Okay. Because if you have doubt, everybody else will have doubt.
The last thing you mentioned where you'll merge all the 3 frames to form a 2D image, like how does that work?
So let's say you are very creative and you came up with the algorithm that, okay, what I'll do is instead of doing like this, inside the image, the thing inside another thing, you might come up with a new format. Okay. You might say, okay, right. Okay. Let's say you decide, okay, rather than having so many frames, I know that, okay, my columns are only 2. So I'll just merge these things also here. And in the code, while I'm displaying, I will display it such that I'll pick 2 columns at a time and display to the end user. Something like that, right? Okay. So, yeah. So people might come up with all kinds of representations, right? People might come up with all kinds of representations. It is up to them. Okay.
Okay.
So it is their own, when you are designing an algorithm, you may choose that, okay, I don't want to represent the image like this. I want to represent image something like something else. Okay. And yeah. Like, for example, you might choose that, okay, instead of 3 numbers to represent color, I'll say that if the number is between 0 to 255, I'll call it red. If it is between 255 and say 511, I will call it 512. I will call it green. And if the number is between 512 and 780, what is that number? 7, how much is 256 times 3? 758 or something. Okay. Now you might say, okay, let's say instead of representing by 3 numbers, I'll represent my color using 1 number. Correct? It's up to you. Similarly, people can are free to come up with their own design of things. Okay, but usually this is a standard practice to do. Okay, perfect. All right, all right. Yeah. So far, everybody okay? Now, another thing to keep in mind that when we are representing a point, we can also call it like a vector. Let's say we have this point or anything for that matter, we can just represent it like a vector. Okay. Like, for example, this is my point x at x comma y. One way to represent it is like a distance from the center. Other way is just put an arrow mark and say that this is my point. Okay. Now, so, okay. Now here it is very simple to you. Okay. So let's say there is a point named let's say there's a point. This is what is the coordinate of this point? Everybody? This is 2, this is 3, right? 2 comma 3. Okay. What is the length of this line? Can anybody tell me quickly?
And plus 4 plus.
If this is 2, this is 3. Okay. So what's the formula of this distance? D is equal to
A square plus B square under root.
A square plus B square, right?
Right.
The hypotenuse is hypotenuse square equal to A square plus B square. How much is A? 2 square.
2 plus
How much is B?
3 square.
So D square equals to
13.
So D is equal to square root of 13. Right? Is everybody okay?
Yeah.
All right. Okay. Now gearing up. Okay. Now. All right. So let's see. Let's draw one point. This is my point P1 this is at 2 comma 3. Okay. And there is another point, say here, it's at 8 comma 4. Okay. What is the distance between them? This distance, everyone? How much is this distance?
Root of 37.
Okay. Okay. Not that fast. Just help me with the calculation.
X2 minus Y.
Okay. So let's draw a triangle here, correct? How much is this height? This height is 3. How much is this distance? This distance is 2, correct? So this, and how much is this total height? Total height is 4, correct? How much is this distance from here to here? It is 8, correct? So how much is this distance? Let's call it A. So how much is A?
8 not 8, it is 6.
8 minus 2, correct?
Yeah, 6.
Because this is 2, this is 8, so this is equal to 6, correct? And how much is this height?
It's the 1.
This is 4, correct?
4 minus 3, yeah.
4 minus 3. So this is height is 4 minus 3 equal to 1, right? So this is 6, this is 1. So how much is this distance?
Under root of 37.
37, square root of 37.
Square root of 37.
Uh,
1 square plus d square is equal to 1 square plus 6 square, which is 37. And therefore d is square root of 37. Right? Everybody okay so far? I know that you have not looked at calculations and geometry for maybe 10 years or 15 years. But yeah. Okay. All right. But this would be so. This is okay with everyone. Feel free to stop me and ask right now if it's not clear. So basically, to find the distance between one point and another, all we did was drew a triangle. Okay, found the base, found the height based on these coordinates, and that's it. So the formula comes out to be, if this is x1, y1, this is x2, y2. So this A is equal to x2 minus x1, and B, the height, is equal to y2 minus y1. And the diagonal, the hypotenuse is going to be a square plus b square. Okay. So like this. Everybody okay? You don't have to memorize anything. It's just simple thing. Is everybody okay?
yes.
Good. So far, everybody's okay, right? No. All right. Now, let's go to 3D world. Okay. Don't use any formula. Derive the formula. So in the 3D world, you have point 1, which is at x-axis 1, y-axis 2, and z-axis again 2, right? We have another point 2, where x-axis is, let's say, 5, y-axis is, say, 10, and z-axis is 10, or let's say 15. Okay, so we have these 2 points in 3D world. Okay, this is the 3D world, this is one point, this is another point. Okay, now, who will help me figure out the distance between these 2 points?
I guess it
root
will be the
of
same
5 minus 2
formula.
का whole square, 10 minus
Oh.
plus 10 minus 2 का whole square plus 15 minus 2
Yeah.
का whole square.
Whole square.
Okay, and the square root.
Yeah.
How did you come up with that? All right, how did you come up with that? Right? Let's just look at the derivation of that formula. All right, let's look at it from the perspective of the shadow of this line on the XY axis. Okay, and how do you do that? We'll just look at the shadow. How do you look at in 2D world? So let's say P1's shadow is 1, 2. Okay, we just eliminated. P2's shadow is 5, 10, right? On this wall, it'll look like here, right? Make sense? No? So if you take this 3D, each point's shadow on without the z-axis, it'll basically be 1, 2, 5, 10, right? Without the z-axis. Are you okay with this?
Yes.
Okay. Now, we find the distance between them. We know the distance is, right? Let's call this distance as d. Okay, we know how to calculate this, right? We can say P1 minus P2 square, and we sum it, right? Now, if you think about it, when you change the perspective, this is how it's going to look like. When you move the camera, it's going to look like this, okay? If you, right? If this is your X, this is your Y, this is your Z, there will be one line going on here. And so we calculated the base of this triangle, correct? We calculated the base of this triangle and height of this triangle. So this base of the triangle is going to be D, the one that you just now calculated, right? And height of this triangle is going to be how much? The Z2 minus Z1, okay? And therefore, the actual distance, this actual distance is going to be h square equals to d square plus Z2 minus Z1 square, correct? So it's essentially the same formula. So the formula of distance comes out to be square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Are you guys okay with this? No?
Sandeep, could you just repeat that for me? Like, I know you shifted the axis from let's say, from another angle. So
Yeah.
where, let's say, Z becomes on top. How
Yeah.
did you get this?
Okay, so look at that, basically what we did, first of all, we eliminated z-axis. Okay, we only talked in 2D. Okay, so if you're holding an line like this, right, the shadow of this one is going to be in the 2D, right? If height is the z dimension, the base we have calculated, correct? Can I
Yes.
draw? Base we have calculated. Okay, like let me see if I can draw it better. Okay, so let's say this is 1 point, or let's say in the sky there is 1 point. This is the P1 and there is P2. Okay, now, right, this is how it looks like. Okay, all right, I'm pretty bad at this drawing. All right. Has he drawn? I remember drawing it in 3D. Yes, here it is. Okay, luckily. Okay, so this one is very clear, right? The Euclidean distance D is x2 minus x1. Basically, we calculated this triangle's height and width, right? Okay, so this is y2 minus y1, and this is x2 minus x1, right? Using Pythagoras theorem, we can say this. This is clear to everybody. 2D is clear, right? Crystal clear, right? Now let's take a look at 3D. Okay, so if let's say this is my first point, this is my second point, okay? I removed the z-axis, the shadow of this is this, correct? How do we calculate? Let's say 2 dash. Okay, this is my shadow of that one. So we calculate this distance using standard Pythagoras theorem. x1 minus x2. And then when we calculated this, this is nothing but the base of this triangle, right? And the height is basically z2 minus z1. And this is that square root of a square plus b square. Okay. And e square is equal to square of this one, which is a square plus b square plus c square. Okay, this is e. Got it? Is it making sense? So first we removed the z-axis and looked at only the 2D and calculated this distance. This distance comes out to be a square plus b square. This a is nothing but x2 minus x1, b is nothing but y2 minus y1, and c is nothing but z2 minus z1. Did I confuse you more?
This fine.
Neil?
With this graph, it makes sense.
Okay.
This a vector, a value, how to like assume this the 90-degree coordinate, how to assume that which coordinate?
How to?
Assume that this coordinate, this the a coordinate, like
It's not
variable
a.
of
It's not a coordinate. It's a value.
value, but how to assume this this coordinate, the
How
right
to
hand side of that, how to find out?
Yeah, it's very simple, right? So if you go up, right? If you go up, how did we calculate this distance, right? Basically, if you think about it, what is this, right? Okay, if you think about there is an origin here, okay? This distance is how much? X1, right? And the total distance is how much from here to here? It's x2, correct? So this distance is how much? X2 minus x1. Got it? Similarly, this distance is how much? This is y1, this is y1, and the total distance is y2. So this distance is how much? Y2 minus y1. Got it? It's the same thing here. Everybody okay so far, right?
Yes,
Okay.
Sandeep.
So,
Sandeep, I have a question. You
yes.
mentioned here E square is equal to A square plus B square plus C square.
Yeah.
Will you explain me this?
Here, right? This one.
Yeah, yeah.
Okay. So you are okay, right? This d square being equal to a square plus b square.
Yes. Yeah.
So we got the base of this triangle, next one. And d square plus
Makes
c
sense.
square equal to e square, correct?
Makes sense. Makes sense. Now I got it.
And you got it? Okay.
Yeah, yeah.
Good. So e square is equal to d square plus c square, and d square is equal to a square plus b square. So we put it a square plus b square plus c square. That's it. Okay. All right. All right. So one of the very important thing that I always want to communicate in my class is that don't assume a formula. Okay. There is no shame in questioning the formula. There have been so many different things that I have seen in my life that I assumed, okay, I actually assumed each and every formula and just memorized it. And I thought that I understood it. But the main problem was that I had memorized the formula. Like, for example, what is the area of triangle? Okay. Now, we know that it is half of base into height. Okay. Even for a triangle like this, like let's say this is the triangle. Okay. Base, and this is the height. And still we call it half of base into height. Now, question is, how did we come up with this formula? So even as obvious as triangle's area, I had memorized the formulas, okay, which is not a good thing to do. Okay, So, but I would request you to just go back and try to derive the area of an obtuse triangle like this. Okay, basically you cut it into two triangles. One is this, another is the outside. Subtract the bigger one from the smaller one. Sorry, smaller one from bigger one, and then you'll get this one, and that's about it. So test it out. Okay, so try to keep things super simple. Try deriving the formulas. There are a few things that are difficult to derive. One such thing is Pythagoras theorem. Rest of the things you can actually just derive. Okay, and all right. Okay, so let's try to write the formula for calculating the Euclidean distance. Okay, so if you have 2 points, point 1 is this, point 2 is this, we can calculate delta x, delta y, delta z, and then we can square all of them, and that's about it, right? So that's the distance between 2 points. Okay, you guys will be able to do it, right? If an interviewer asks you to do it. So the distance between these 2 points is 7. Okay, 7.07. All right. Now we can create a n-dimensional method to do it. Okay, who can help me code it? I'll just code it. Okay, define distance. This is my P1, P2. Okay, P1 can be of any dimensions, not only 2D, it could be any dimension. If it is one more, we'll just add one more here. Okay, let's say instead of Z, we have, let's say, Q2 minus Q1 whole square. Okay, and then let's say R2 minus R1 whole square, like that. Okay, so for any number of dimensions, you can have the same formula. Okay.
Sandeep, I have one question. So, I mean, what is the significance of, this, we are studying this Euclidean distance. So what is the significance of using Euclidean distance in LLMs? I mean, what is the major we can do it?
Yeah. So what we are going to do in simple words, and before we forget, okay, we have two texts. Okay, we will find similarities between them using the Euclidean distance. We'll convert each of the texts into a bunch of numbers, and then we'll calculate the distance between them. Okay?
Okay.
That's why we are studying the Euclidean distance. Okay? All right. So who can help me code it? You can think of P1 to have X coordinate, Y coordinate, Z coordinate, or any number of dimensions for that matter. So we'll not assume it to be 3D, we'll assume it to be infinitely many dimensions. Okay. Yes, go ahead. Okay, don't look at this solution.
So typically this text, when it gets converted into numbers, how many dimensions it uses?
I don't know. It can be any. It can be 2D, it can be 3D, it can be 4D, it can be 5D. So
Can
any
you just use like, can you just use like a loop, like
Yeah.
for I in range
Yeah.
the P1?
Okay. For I in range, and we'll say length of P1. Yeah.
Like the P1.
Okay.
Then just do P2 minus P1. P2 brackets I minus P1 brackets I.
P2 bracket I minus P1 bracket I. This is the D coordinate D. Okay. And I will just keep a total square equals 0. And we'll just kind of keep on adding this to that, right? We'll say total square plus equals to d into d. And at the end of it, we'll just return math.sqrt of total square. Make sense? Is it making sense?
So that would miss the 0th index, I guess, because you are taking the
Come again?
So that would miss the 0th index of P1 and P2 because you're taking them there. It would start from 1. It would start from 1.
No, I think this array is 0 based only. Okay. Let's see if it is correct. Distance. Where was this question, right? 1, 2, 3, 4, 6, 8. Okay, it should be 7.0, right? This 1, 2, 3 and 4, 6, 8. Okay. I'll just convert this into an array instead of a tuple.
Yes.
Okay. Do you think it'll miss out? Is this code okay? Gaurav?
Yes. Yep.
Okay. Let's see. What does it say? It says math not defined. Okay, I'll just import math. It looks okay to me.
Yeah.
Go ahead. That doubt that you have is probably others are also having. Okay.
No, so I thought that since we are using length, I thought that it would start counting from 1 instead of 0.
Right. Perfect. Is everybody okay so far? So this is our Euclidean distance formula. Okay. Happy, everyone? All right. So we just coded it, and basically it's the same thing done here as well. Okay. Here unnecessarily there is a method called zip. What zip does is, okay, take a look at this zip. Okay. What zip does is it brings the two things from both the array in together. Okay. I'll just show you how it looks. Okay. I converted it into the list. So you can see one from left-hand side combined with one from second side, 1, 2 from one side combined with 6, and 3 combined with 8. Make sense, everyone?
Gaurav, can you mute yourself?
Yeah. So,
Go ahead, Sandeep.
Yeah. Okay. So here you can see that the zip basically does nothing but bring the values together. Now, since I can't display zip directly, that's why I have put a list before it, because zip is an object. Okay. That's why I converted that list so that we can print it. Okay. So basically that's what is going on here. So we zipped the values together. The x coordinate of this one comes together with the x coordinate of the second one. Y comes with y, z comes with z, and there we have it. Okay. And then here we are again looping, going over the values, subtracting x and y together, then squaring it, then summing up the array, and that's about it. Okay. I like this code much more, much cleaner than this code. Okay. Number of lines may be 2, but this is much more cleaner. Okay. All right. So we can basically just extend that formula to anything, right? Now, let's try to do this. Last time we did this. Okay. Last time what we did was last time what we did was we took last time what we did was we defined this method above, okay, here, okay. All right, where is my key? Okay. Yeah. So, all right, I'll have to read it from one level above. Yeah, this one worked. Okay. Now, yeah, we talked about all of this. Okay. So we read the file where I stored my OpenAI key. You guys can also generate your OpenAI key using their website. Okay. And here we wrote this command, Unix command, to check if this thing is working or not. So curl is a Unix command with which you can download any URL. Okay. So curl, we are asking curl to call this URL. Then we are passing the header saying that the content type is application JSON. And then we are passing this header telling what is the authorization key. Okay, we are passing that. And then we are passing the data. So this is the standard arguments for the curl command. -h is header, -h is header, -d is data. And in the data, we are passing this data. And OpenAI expects us to send the data in the form of JSON object. This is called a JSON object. Curly bracket represent the dictionary and the square bracket represent the array and so on. Okay. And here we are passing this value saying input is equal to this product is really good. And we are also telling what is the model. Okay. Now it gives us this bunch of numbers. Okay. Let's just test it is working. Yes, it is working. So you can see that it has given me the embedding. So LLMs, that the one that you're using, the ChatGPT one, they basically, instead of asking it to generate text, you can get the direct signal from its brain, and that's called embedding. Okay. So rather than it telling you the text, it is giving the brain signal in the form of these numbers. Okay. So these are called embeddings. Every vendor, everybody who is providing an LLM, they provide an API for embeddings also, whether it's Gemini, whether it's OpenAI. Everybody has their own embedding format. Okay, so this is the embeddings that you see. All right. Now, then we have defined a function called get OpenAI embedding. Now, instead of using curl command, we are using Python's URL lib.request.request. This is the object which basically lets you define a request object. You are providing URL, you are providing data, you are providing headers, and you are providing the method called, we are saying post. And then this is your request. And then you can simply say request, URL lib.request.url open, and you can request you can send this request. It gives the response. From the response, what we are doing is we are converting that response into JSON object, and then we are extracting the embedding part. Okay, so this function basically gives the embeddings for anything. So it converted, the way you can think of it is that this function converted our text into meaningful numbers. Okay? Everybody okay?
Yes.
Why
And
is
we
it, Sandeep, that we
Sandeep,
just
one question.
sorry, Sandeep, why is it that we just put data 0, not like the whole data? Is there any particular reason for that?
where? Here.
In line, yeah, exactly, line 27.
Yeah. Because see, the thing is that here you can send a request with many text, many sentences. Okay. And it can generate for each, let's say 100, you have 100 paragraphs of text. Okay. You can send those 100 separately and it can give you the embeddings for each of the 100. Okay. Okay. That's why we are just picking the 0th one from it. And that's it. Okay. All right.
So
So
when
in
So,
this
we
last
see,
point, don't we need embeddings for everything that we assigned?
can you repeat on that?
Yeah, the last point, can you please explain it again? I mean, if let's say we are
Basically,
sending
it is the
data.
response. See, this is the raw response that is coming from their server. Okay, this is the raw
Okay.
response. Okay, so this is how it is. First, there are curly brackets. Inside that, there is data. Inside the data, there is an array, right? So we are saying, first, we are saying here that give me data. Okay, that's what we are saying. Give me data. So we are basically saying response, give me data. Okay. After that, inside data, there is an array. So we are saying give me the 0th element of it. Then inside this, again, when we got the 0th element, this is again an object. So we are saying give me that value called embedding, right? That's it. Got it?
All right.
So that's what we are doing. So we are basically using their API, converting that text into JSON object, and after that, we are doing the rest of it.
so
Okay.
when we are saying that it will give the embedding, so it means whatever the query that we have given to the chat GPT or any
Yes.
LLM, the converted numbers it will give for all the
Yes. Yes. So instead of it telling you the answer of how are you, it is telling you the meaning of that text in the form of these numbers. Okay.
Okay.
Right. Now, what we did last time was this.
I
Okay.
have one
Sandeep,
question.
one
Sandeep,
more
sorry.
question.
So basically, is this for the how word, this embedding, or it's for the whole how are you embedding? I mean,
It's how are you embedding?
okay.
Okay.
Yeah.
Sandeep, this thing detect the error. Like I provide the prompt as the error message, then they find out the which type of error comes to the our source code. This thing is do via
As
this.
in?
Like we provide the error message, then the LLM figure out which type of error happened in our source code.
Yes, exactly. Exactly. So what you can do is if you have like 100 things in the bucket, what you can do is say you have a big documents, right? Let's say you
Right.
have 100 documents, okay? And you are looking for a question, okay? You have 100 documents, you are looking for which document contain this question's answer. So what will you do? You will calculate the embedding of all 100 documents. Okay, now you got 100 documents embeddings. You will calculate the embedding of the question that you are searching for. And now you got this embedding. Now you will try to find the distance, Euclidean distance of the question with each of the document. And you will find that the document which is closest to you, which is closest, would contain the answer of this question.
That means we need to train this LLM model. They automatically already.
See, training is a wrong word to use here. Okay, this is already pre-trained. We are only using it.
But if we want use to our data set, like the my custom error or some the
Right now, the strategy we described does not involve training. Okay, so let's say you have 100 documents. Okay, document D1, document D2, document D3. Okay, like that. For each of them, we calculated embeddings E1, E2, E3. Okay, now your question is there. Again, for question, we calculated the embedding, right? Now what we do, we find the distance between this question and E1, this question and E2, question and E3, and whichever comes closest, we call that to be an answer.
like yeah, that is understand, but I give you one example. Like I am working of the electronic modem or something like that. Like
Yeah.
one bit of change of any error messages come to the our log file, right? We have the thousands of logs this type of error, and
Yes.
then the one bit of change, there are different type of error. We define that this LLM model or that thing figure out the which type of error happened in the behind scene when the width is little bit change of the every different log. So that we need to change the our LLM, like train to the
No, see,
LLM.
same way. The thing that I just described, you can use the similar strategy.
Hi Sandeep, I think he's talking about RAG mechanism.
Yeah, this is called, what I'm explaining is also basically the fundamental part of RAG. Okay. So essentially, what we are trying to do here is find the distance between question and the error messages. Okay. And it will basically figure out which of them is closest. Okay.
Sandeep, I have a question. So
Okay.
how does it convert the word into an embedding? Is there a logical representation of it? Is there a significance of it? I mean, it can be out of the scope for this session, but
Yeah. It is basically a big trained neural network, which basically, what is a ChatGPT, right? A ChatGPT or any large language model, any AI model predicts the next word, right? So instead of extracting the next word from it, if you extract the signal, the numbers from the layers, middle of the layer is like cutting cutting open the brain and extracting signal. These are those numbers. These numbers individually you can't figure out. You can't say, okay, the first number represents the sentiment and second number represent this and third number. No, nobody knows. Okay. The only important thing people figured out that these numbers have a very interesting property. The things that are similar, the Euclidean distance of those are going to be smaller. Okay. Let's just take a look. Okay. Right. So let's take a look at the thing that we discussed so far. Let's move ahead. Okay. You'll get a feel. Okay. Right. Like for example, let's try to calculate the distance between cat, dog, car, bike. Okay. So we calculated the embedding for cat, embedding for dog, embedding for car, embedding for bike. Okay. Now, we calculated the distance between cat and dog. This is the distance between cat and dog. This is the distance between cat and car. This is the distance between cat and bike. This is the distance between bike and car. This is the distance between bike and dog. And let's take a look at that. Okay.
will the embedding for a specific word will always be the same?
Just a second. I will give me a moment. I forgot to copy the code that we wrote.
Sure.
Just give me a moment. We wrote just now, right? The code for this. Yeah, this one. Okay. Okay. So, yes. So you can see here, the distance between cat and dog is 0.52. Okay. while cat and car, the distance is 0.56. Which one is closer? So cat is closer to dog, then cat is closer to car. The distance between cat and bike is 0.61. So cat seems to be closer to car as compared to bike. Probably just checking with these letters. Okay. Now here, the distance between bike and car is 0.54. Okay. So you can see that bike is closer to car than it is to cat. You can see that?
Okay. Yeah.
Right? Distance between bike and dog is 0.58. Okay. So you can see that bike is closer to car. No, bike, sorry. Bike and car. Yeah. Bike is closer to car, right? As compared to dog. Okay.
So can we say that for a specific language like English in this sense, these embeddings and the distances will always be the same?
Are you saying that every time we call this, the
Yes.
embedding is going to be same?
Yes.
Yes. You can just test it out. I will just show you. This have to be same. Okay. If I just call this model twice. Okay. And
okay.
Right. And then calculate the distance between cat and cat. It should be 0. Okay. This should be 0. Okay. Because the large language model should not change the embedding. Okay.
Right.
Otherwise, you will have to re-index all of your
Yeah.
documentation.
Yeah. And the
Okay.
answers will be different every time.
Every time. Okay.
Thank you so much.
Okay. Moving on. Is everybody on the same page so far?
Sandeep, I had a doubt related to how you're accessing the OpenAI through the API key. Can you explain that once?
This one here. Okay. So I have basically saved my key in a folder. Okay. In a folder named OpenAI_key. I went to their website. I put my credit card and got the key from them and saved it in this particular file. And then I'm reading that file. Okay. And once I've read the file, then I'm making the call to their API. Okay. So first I tested calling the API using a Linux command rather than writing Python code. Once that was working fine, then I went ahead and wrote this function. Okay. First, this function takes only the prompt. Internally, it creates headers, then data, then encodes the data into the JSON object using JSON.dump. It basically creates a string and then converts it into UTF-8. And now my data is ready. I'm sending the request to this particular URL, and the URL is this. And then I'm passing the data, I'm passing the headers, I'm making the method is post, and this is my request object, and then I'm opening the request object connection. Okay. And once I got the response, I convert that response into, Python dictionary. Okay. After doing that, I basically extract the particular value. Okay. And that's about it.
So the
Got it?
line 22, where the request is equal to URL library, is it equivalent to like giving a prompt and getting a response? Or
Yeah.
because okay.
Yeah. Instead of response, here we are not asking it to generate response. We are asking it to give us embeddings. Okay. You can see the URL. You can see the URL. This
Yeah,
URL is for embeddings. Okay. So when we are passing this URL, it's for embeddings, not the chat response. Okay.
Okay. Got it.
So instead of using the UI, we are using the Python code to extract from the URL. Basically REST call. Okay.
Sandeep, I have one question. Like in line number 12, you have given, OpenAI key.
Yes.
So So from where, I mean, is this the same which you have?
Yeah. This is the variable. This is the variable that I loaded above. Okay.
Okay.
Yeah.
So I mean, how we can get those API
You have to
opening?
go. You have to go to their website and get it.
Okay. Okay.
Okay.
Okay.
So yeah, if this key get, I'm not showing you the key because if this
Yeah.
video,
Yeah.
right? And I like last time I had to delete all my keys. Okay, after the video. Anyway, never mind. So I just have to get the key and that's it. All right.
Okay.
But yeah, I do not want to right now ask you to use the something else. Okay. Right. This is easier. I want you to learn a couple of things here. Number one, making an API call, or using the scraping websites URL, calling a URL. That's first thing I want you to focus on. Second thing I want you to focus on the JSON object. Okay, go through the JSON dumps and JSON loads, both of these functions, each part of this code, and then experiment with calling it on different texts and come up with some useful ideas on where to utilize this. Okay, there are so many use cases of this, and it's just a matter of figuring it out. Okay, so here I had last time tried to visualize it. Okay, I had tried to visualize it in the last discussion. We had a last discussion, right? Was it this one? I was going through. Yeah, this one, was it this one? Yeah, this is the one that we experimented with, right? So, yeah. So we experimented with these words, okay? So we showed that if you take these numbers and try to cut down all of the dimensions and put them in two dimensions, they'll look like this, okay? And yeah, we used an algorithm last time called PCA. PCA converts any number of dimensions into a few number of dimensions. That's what we have done. This is a machine learning algorithm called PCA. And using PCA, we can reduce the dimension. If you take a look at the embeddings are even the empty text. Even the empty text would have the same size array, 1536 numbers representing one letter word or empty word or 1,000 words. It would return the same number of values. Okay. And yeah, and we tested on this. We also calculated, all right, the distance between these sentences. Bharat Mahan Desh hai, Bharat Mahan Desh hai, India is a great country, and the sky is blue, US, Canada are nearby, cow eats grass, buffalo gives milk. So we calculated these things last time, okay? In that discussion, we were able to, we were visualizing these things.
Sandeep, one question over here. Like, are these touch points, in case of text specifically, is it only 2D, or which scenarios would it be 3D?
Which one?
So are this text comparison that we do, like in ChatGPT, we add a prompt and we get a response. So internal embeddings are calculated based on 2D representation or 3D representation of the
Take a guess.
plotting. I'm thinking maybe 2D.
No.
3D.
It's 1500 dimensions. Okay.
1500. And
Yeah.
those are reduced to lowest dimension by PCA, is that it?
Only for this visualization. We wanted to put it on the graph. So each of these sentences that you see on the graph, two-dimensional graph, they are in 1500 dimensions. So we kept on bringing it down and put it into two values and then plotted on this graph. Just for this 2D visualization, we brought it down to that. just to show you that the distance between the things basically are very close by. You can see India is a great country. Bharat, this is in Hindi, it's written like Bharat ek mahan desh hai because this plot is not able to show it properly, and so on. So you can see that it has figured out that these are three things mean the same. Okay. US and Canada are
Okay.
nearby, sky is blue, cow eats grass, buffalo gives milk. You can see the distance and the visually, the closer things have closer embeddings. Okay.
So is it safe to say that like internally when they represent the data structure of the embeddings, it would be like a kind of tensor data structure? Array of vectors, array
Yeah,
of array
yeah,
of
yeah.
vectors.
It's basically one-dimensional tensor. Okay.
Okay.
It's basically one dimension. I'll just show you here. Like say, for example, here we calculated cat, dog, bike, and all, right? Let's take a look at how does that thing looks like, okay? Now look at this, cat, okay? Cat is an array of some numbers. Let's take a look at the length of this cat, 1536, okay? Similarly, you can check length of dog, 1536, okay? And if you, even if you have, let's say, right, let's say sentence one, okay, and here I'm saying, okay, okay, so I'm saying calculate, okay, let's say sentence one is, again, give me some good sentences, something which may look very strange. The Queen of England. Okay. All right. And okay. Let's take a look at these three sentences. Okay. Let's take a look at this. So we converted the Queen of England into this embedding, right? This one again and this one again. And then now I'm going to calculate the distance between these two. Okay. And sentence one. Okay. And now sentence two and sentence three. Okay. So, all right. Sentence one and sentence two is still closer. Okay. Okay. I'll do sentence one and sentence three. That is much better. Okay. So the King of England, the distance between King of England and Queen of England is smaller. Okay. While this distance is more. So it does understand the meaning of sentences. Okay. Are you guys okay?
Sandeep, I
I
have
have
a
a
question.
question.
Yeah.
Okay, to use embedding, it's mandatory you to use the key. Without key, any other alternative we can try?
You can use the open source models such as Universal Sentence Encoder. This is a lightweight model. Okay. You can try using that one. All right.
Okay.
For a given model, the encodings will be same, right? But for different models, the encoding would be different.
Of course, yes.
Yes.
Even like in case of ChatGPT themselves, if they just make tiny modifications to model, embeddings will be entirely different. Okay.
Okay.
Embeddings for 3.5 and 4 will be different.
Yes, entirely different.
And the reason for
when we are chatting
the
with
first and the reason for the first one and the third one, the King of England and the Queen of England being more similar, is because of the relevance of the words, right? The England is same, of is same, the is same. Probably that is
Because
why
no,
embedding.
because no, based on the meaning, it does understand the meaning of queen in context of England, in context of game of chess. Okay.
How does it? I mean, and that's kind of difficult. It's a computer, right? It understands numbers.
So basically, the way human has learned the meaning of words, how did you learn the meaning of words? By reading lot of text, correct? Similarly, the LLM read through all the text of the internet, trying to guess the next word to predict, right? Kept on learning to predict the next word, and luckily, it learned the meaning of things. Okay. So we learn
Sandeep,
all
when
of
we are
that.
when we are conversing with a chat GPT kind of a thing, right? So it understands all the context, and there can be any number of context. So can we say that it has learned all the context?
It has learned it has basically learned the meaning of sentences just like me and you.
Yeah, basically, let's say even if you're saying how are you, depending on what the previous conversation or the previous kind of text
So it
that was
basically
sent,
goes like
it
this.
responds differently.
Yeah. So it basically talks.
Number of combinations could be very high, right?
What?
The context would be like one number of combinations for those contexts. For example,
Yeah, it
I
has
say
not
one
memorized.
sentence.
It has not memorized. It has not memorized. It has learned. Okay. There's a difference between learning and memorizing, right? Okay. We will talk about this in much more detail in
I have one question. Like, so LLM, we train it once. So what happens for current affairs? Like something, who is the richest person for this year, or kind of few things. So they should learn again, right? Few things.
Yeah.
So how does it work? How do they relearn or update models?
They retrain the model.
So whole throughout internet, they will go through again and again, right?
Most of it, yes. Okay. We'll talk about the models and large language models. Okay. For now, I would want you to experiment with the embeddings. Okay. You can assume that the LLM is able to convert. There is a magical model called any model. I've also posted a USC model, right? They all convert text into a bunch of numbers, and then you can do a lot of magic with these bunch of numbers. Okay, you can build recommendations, you can build search engine, you can build so many things. Correct. Let's take a look at the last one. Okay, imagine that you're building a very simple sentiment analysis tool. Given a text, tell whether it's a positive or negative. Okay, how would you build it? Okay, so you want to build a simple sentiment analysis tool which basically tells us whether it's positive or negative. Okay, so let's say we have two texts. One is the product is amazing and the product is not good. Okay, and we have a word positive and we have a word negative. Okay, we computed the embedding for positive and negative. Okay, so we have now 4 numbers, right? This product and this review, this positive or negative. Okay, now, all right. So you can see The product is not good and negative is it looks closer, correct? Product is amazing and positive, they look closer, correct? Let's compute the distance between good review and positive word. Okay. It's coming to 0.6679. Okay. Let's compute the distance between bad review and negative. Okay. Now, let's also compute all the distances. Okay. Right. And I think a better thing to do is take a bad review and compare it with positive and negative, and take a good review and compare it with, okay, both the keywords. Okay, so this is a good review. So the good review is the distance between good review and positive sentence, positive word is 0.667, and good review and negative one is 0.69. So which one is, so is this review positive or negative? So the distance between this review and positive word is 0.667. The distance between this and negative is 0.698. Which one is, so this one is a good review or bad review?
Good review.
Good review, because it's a
Good
positive.
review.
This is closer to positive word, correct? This review is
Yes.
closer to positive word. This review is not, as compared to, if you compare the distance, you can see that, right? Similarly here, this is a negative review. The distance between this review and the positive word is 0.68. And the distance between this review and negative word is 0.63. So is this review negative or positive?
Negative.
Negative, right? Right? Using this logic, we can write a simple function, right? Given a review, it will tell us whether it's a negative review or positive review. Okay? So we can take the let's say this review and compute its embedding. Then we have already computed the embedding for the word positive and negative. We don't need to recompute it. Then we compute the distance between the review and the positive word, review and negative word, and there we go. Okay. All right. Now, I went to the website, Amazon. I copy pasted actual review. Okay. And there we have it. Okay. So this is a negative review. Okay. You want to test it right now? Let's take a look. Amazon. It'll show you my purchase history, but that's okay. All right. Let's take a look at, let's say, review of some of the products. Let's say this one. Okay. And there are 86 ratings, out of which let's take one rating from negative. Okay. And why it's going that side? Dude. Why it's going there? Okay. Let's take a look at this one. Does it understand French? Is this French or Spanish? I don't know. Okay. And there we have it. Let's see. Is positive. Okay. We just copy pasted. Okay. I'll just put it in double quotes because there seems to be a triple quotes. Triple quotes means even if there is a new line, it will take care of those new lines. Okay. Python has something called a triple quotes. Man. Okay. Will it work like this? Okay. So it says that it is a negative review. You see the magic here? And if I just say copy paste this one, right? Okay. Again, I'll just put like right? So it figured out that it's a positive review. So we just built a good sentiment analysis tool. Are you happy?
Sandeep, can you try taking like a 3-star review just to see, like, half and half? What does it feel like?
Okay. Okay.
Yeah, I was about to ask the same question. Like, if it's positive and negative both, then how does it respond?
Okay. Let's say this one. Okay. So this is actually positive if you see. Okay. So basically the distance could be fairly difficult, but because we have written this distance positive and negative is less than, even with single data point, my 0.01001 difference is still, it'll basically jump to one side. Okay. Even if it's equal, it will say it's a negative review. Okay. So we can try. Okay. Okay. Right. Amazing image quality. The only issue is it runs out of RAM if you open too many apps, but I find to work around by managing this. Looks like a positive review to me. Let's see. Yeah. So 3-star rating, 4. Oh, this is 4-star. Man, this interface is messed up. Oh, good. All right. Is there a, I'll just go to 3-star.
Filter there, 4 stars can be.
Okay. Yeah. This one, it went for negative. I checked reviews before buying it, but it's not that impressive as per me. It's just okay. Sound quality nice, but pixel quality lacks blah and blah. So it has taken it like a negative. All right.
There's more negative wording.
Yes. Okay. So it's the overall emotion somehow it has figured out. Okay. And it is doing pretty well on that. Better than me at understanding all these languages. And yeah, does a good job.
Sandeep, I have one question. So before building this LLM models, this sentiment analysis was not built in the machine learning. It was not there.
No, there were other techniques. So there were other techniques, but they were not this foolproof. There were techniques right. So the embedding idea came much before LLMs came. Okay. So we built the embeddings using other techniques. Okay. And the sentiment analysis, which was there even before the machine learning models, was very, very rudimentary. The way it used to do is take the positive words from the text, give them numbers. So there was a dictionary which gives you 0 and 1 for each positive word, and that's it. Okay. And just basically sum up all the positive sentiment, sum up all the negative words, and subtract positive minus negative, and that is called sentiment analysis. Okay, but that was like very, very rudimentary. It did not really work that great on complex sentences. Okay.
So this TF-IDF, and I have heard of this thing. I don't know that.
TF-IDF is nothing but number of words, word counts.
Oh, okay.
Okay. So
That
what
was
people
weighted
usually do
averages,
is
right?
What?
That was weighted averages, the one that you're talking about. You assign weight.
So you count the words, and see if these are common words. Overall frequency of all the words across all the reviews. Divide that by the total counts of each word, like in particular sentence. Count of a review divided by count of each word from the review, and that's what we call it, like TF-IDF. Term frequency inverse document frequency. Okay. All right. Term frequency in this review divided by the frequency of this thing in all the reviews. Okay. That's called TF-IDF. It's nothing but basically word count. Okay. So what people used to do is they used to find similarity using that technique. They'll take one sentence, another sentence, find the words in this, find the words in this, see how much word counts are matching, and that is what was used as basically the simple way of calculating whether this is French or English and so on. Okay. So TF-IDF was like the very rudimentary of word count. Okay. Something like giving a text, figure out whether the text is in French or English, Hindi, or what. So you will basically take the count of letters, like which letter is coming very frequently, and then basically compute that. So most of those things were word count based. Okay. But this one is the most meaningful one, meaningful way of converting text into bunch of numbers. Okay. I realized that this would be very, very useful when you think about your machine learning models, think about other things, right? Like, for example, one of the common question is that, let's say you want to build a product to product recommender. Okay. On Amazon's website, you have these product to product recommender. Like here, if you go up to the website, I'll just go back. Yeah, let's say here, okay, let's say you want to show here that similar product to this one are these. Okay, so what you can do is you can basically prepare the matrix between basically take all the reviews from Amazon, take all the products, like their description from Amazon, and find, let's say I'll just take the description between, this is one product. Okay, I will just say this is product number one. Okay, I will just write it in a multiple line. Okay, cool. So this is product number one. Now product number two. Okay, you can see I am going to just go down to one more TV, or yeah, let's just take one more TV. Okay, I am taking, this is another TV. Okay. Right, this is two TVs. Okay, now let's say product number three. Let's say product number three is a little different. Okay, let's go down and find this one. Okay, right, let's say this one. Okay, and between these ones, we can calculate. Okay, we can calculate distance after computing the embedding. Okay, so we have got product one, product two, product three. Oh, I keep on getting lost in this notebook. Yeah. Okay, we calculated the embedding of this one, this one. Okay, we calculated the embedding of this one. Okay, using the OpenAI, we asked for embedding of this one, right? And then we can simply use our calculate distance formula, calculate distance between PD1 and PD2, okay? And calculate distance between PD1 and PD3, okay? So now you can see the distance between product 1 and product 2 is 0.45, while the distance between product 1 and product 3 is 0.75. Make sense?
Sandeep, is there any way, any resource which you know where we can see what all people are using LLMs for, as let's say like these kind of use cases?
Just search the internet, okay? And the best resource for you would be probably OpenAI, okay? So one is, like the one is like go through the prompts. Like people are doing so amazing things with all kinds of prompts, okay? And other is this location, okay? Here you will find the capabilities. You can build search engine, you can build clustering, you can build recommendation, anomaly detection, diversity measurement, everything, okay? So there we have it. All right. Okay. Yes. That's pretty much. We will carry on from here tomorrow at the same time. I hope this was useful. Right. I know that right now I cannot jump into how does the machine learn and so on. I will talk about how does a machine learn, how does an LLM learn. There is a separate session for the same. We will also talk about like exact semantics of all the things about transformer and all that, right? But in very, very simple words, if I have to say in one single sentence, like we have a large machine learning model which learn to predict the next word, and then we use that model to, instead of extracting the next word, we just extracted the emotion, like the bunch of numbers, and that's what is embedding. Okay, so yes, we will go into much more details into if you have to design it and so on. But right now, what I want to focus is that what I want to focus is that learn to use this tool. We will learn to build this tool later. Okay, and yeah, so that at least you will get curious, and now you are asking me a question that how it's working, right? And rather than me, if I start to teach you first and then you tell me, then what's the point of this? You are just boring us with all the details. Okay, so yeah, I want you guys to start using it, and trust me, this does not require you to understand the neural networks or any other thing right now. Okay, this only 90% of the work you can actually get done through this much understanding. 90% of the AI engineer work and generative AI work you can get done right away after this discussion. Okay, so yeah, so this way, I mean, the idea was to help you learn how to make a URL call, API call, right? So I thought that I'll take a leap and move to doing some real work. Okay, I hope this Python session was useful to you, and have a good day. We'll see you tomorrow at the same time. Bye-bye.
Bye.
Thanks.